Hello students, this video is powered by Synthesis Tutorials. So in today's video, we'll be starting with a new chapter, that is matrices. This is a completely new chapter for you children, but then this is an easy one. So we'll be just starting with the basics which are there. So the first thing is, first of all, what are matrices? So matrices are actually plural form of a word that is called matrix. Okay, so the plural of matrix is matrices. And what is a matrix? It is a rectangular arrangement of numbers arranged in rows and columns. So when you talk about rectangular arrangement of numbers, children, it can be like this. Suppose this is A and B. Okay, or it can be like this: A, B, C, D. Okay, so this is the way in which you are writing numbers. So this is A, B, C, D, E, F. So this is also a matrix, and if you want you can write it like this as well. So this is A, B, C, D, E, F. So these are all the example of matrix. So what is the prerequisite or the necessary condition for a matrix? The condition is that there should be a rectangular arrangement of numbers, and they should be arranged in what? They should be arranged in rows and columns. So clearly you can be knowing what are rows and columns, children. So here if you see, if I just take first of all, this is a matrix. I hope you all understood. When I talk about rows and columns, suppose I am writing like this. This is A, B, C. Okay, and this is D, E, F. So you all know already that this can be considered as the first row. Okay, and this is considered as a second row. So basically what we say, the horizontal lines are called rows and the vertical ones are called columns. So this will be called our first column. Okay, this is my second column and this is my third column. Now why is it important for you to understand that what is the concept of row and column, children? Because here we will be introducing a new term that is called order of a matrix. So for knowing that, you should be first knowing that what is row and what is column. Okay, so suppose for example, if I take, suppose I have a matrix like this: 2, 3, 1, 4, 2, 5. Okay, so here this is first row, this is second row, and this is first column, second column and third column. So basically in this particular matrix I have 2 rows and 3 columns. Okay, once you are done with the understanding of this part, then we can now go to the next part, that is called order of matrices or order of a matrix. So what is an order of a matrix? So the normal formula for this order is what, children? This is equal to number of rows, okay, into number of columns. So actually what are you doing here? You are just representing this particular matrix in form of number of rows and columns. Okay, so suppose I am writing that, suppose this is the example which I have: A, B, C, D, E and F. So clearly you can see here how many rows I have 2 rows, and how many columns I have 3 columns. Okay, so how will I write the order of this matrix? The order of this matrix will be written as 2 into 3, number of rows into number of columns. So if in the question they are asking that this is a particular matrix and then write down its order, so you will be writing like this: 2 into 3. Alright, now the next thing which is there, children, is how do you represent this matrix? So any matrix is being represented by a capital letter. So for example, if I want to represent this matrix in terms of its order as well, so it will be represented as A, and in the subscript you will be writing 2 into 3. So if I just want to explain 1 or 2 more orders to you, like how to write orders, I can be taking like this, children. Suppose this is my matrix 3, 5, 1. Okay, so how can you represent this matrix? Easily you can see here I am having 1, 2, 3 rows, and how many column I have? Only 1. So what will be the order of this matrix? The order of this matrix will be 3 into 1, number of rows into number of columns. And if you want to represent this particular matrix, how are you going to represent this? You are going to represent it like this: A, 3 into 1. Okay, and then suppose I am taking like this 3 5 1. So here clearly you can see that how many number of rows I have only one row, and how many number of columns I have 3 columns. So this will be represented as A 1 into 3. Okay, so this is the second thing which I am getting. That similarly, if you can see, the terms of these two matrices are clearly same, but the way we represent this is completely different. Always number of rows is written before the number of columns. Okay, so this is called order of matrix, and now we'll be moving to the next term, that is called elements of matrix, children. So what does that mean? I'll just let you know. Okay, elements of a matrix. Elements of a matrix. Now, as the name suggests, children, when we talk about elements of anything, what does that mean? That the very basic thing, the number or the entity which is there, the number or the entity in the matrix. So how many elements are there, how many units are there in that particular matrix, that is called elements. So suppose I am taking this particular matrix A, B, C, D, E, F. So clearly you can see how many numbers are there, children. There are 6. So the elements of this matrix is 6. And then if you want, how can you, if suppose you have been given a big matrix, suppose you have been given a matrix A, and the order has been given 4 into 6, and then now suppose you are being asked that how many elements are there in this particular matrix. So your answer will be, elements will be equal to 4 into 6, which is equal to 24, children. Okay, why? Because here number of rows into number of columns is going to give you how many elements are there. So this is a short way of finding out that how many elements are there in a particular matrix. Okay, so this is 6, and then what is in general elements, like you are counting how many units are there. Suppose if this is my matrix, then what is the, first of all, what will be the order? The order will be equal to 3 into 1. And then if you want to find out the number of elements, there are 1, 2, 3. So you can write down 3, or else here from this formula also you can be getting that 3 into 1 is equal to 3. So the number of elements are equal to 3. Okay, so basically how many units are constituting this particular matrix, that is called the elements. Okay, and then we'll be moving to the next thing. The next thing is types of matrices. Okay, so in types of matrices, basically there are 6 types, children. So we'll be talking about them. So the first one is called row matrix. So as the name suggests, children, the row matrix will have only one row. Okay, so this is my condition. So only one row means, children, what you can be, example can be like this. Suppose A, B, C. Okay, so clearly you can see here that what is this? What is the number of thing which is there? Number of rows here is 1, and what is the order of this matrix? It is 1 into 3. So this can be considered as a row matrix. So suppose, and one more thing, children, this row matrix is also called row vector, but then you will be using only row matrix. So if I want to give another example, this is also my example 2 and 3, suppose I am taking. So this is also row matrix. Any number, like suppose you are taking 3, 4, 5, 6, if it is having only one row, it is called row matrix. Okay, and the next thing that I'll be talking about is the column matrix. Now as the name suggests, children, what can be column matrix equal to? The matrix which has only one column. Okay, so if I want to give this in the form of example, you have to always remember, children, that in a row matrix this will be your order 1 into 3 or 1 into 4 or 1 into 6 or 1 into n. So 1 into n is going to be your general formula. And when you talk about column matrix, means what? It has only one column, and then how are you going to represent that? Suppose this can be represented like this, A, B, C. So clearly you can see here you are having 3 rows. So what is order of this matrix? It is 3 into 1. Similarly you can take like this. Suppose this is my matrix 3, 1. So what is the order of this matrix? 2 into 1. So what is the general form of this particular column matrix, children? How many number of rows are there? If number of rows is n, then n into 1 will be my general formula for the column matrix. Suppose I am taking like this, wherein I am taking 4, 5, 6, 7. So how many number of rows are there, children? 4. So what will be my order? My order is 4 into 1. Okay. So what are you seeing here basically? That in a row matrix it is 1 into 3 and in column matrix it is 3 into 1. So this is the way, and the prime condition is that only one row and only one column. The third thing which is there, children, if you see, that is called a square matrix. Okay. So this is our square matrix. Now what does this mean, students? Square matrix means what? A matrix which has equal number of rows and columns. So means what, children? So suppose, see here. This is an example A, B, C, D. So here you can see how many rows I have. I have 2 rows. Here I have 2 columns. So square matrix has equal number of rows and columns. Equal number of rows and columns. So this is the example which I have given. So what will be the order of such type of matrices, children? It will be always like this. See, 2 into 2 or 3 into 3 or 4 into 4. So these are the examples of a square matrix. What else can be written like this, children? Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is also considered as a square matrix, and the order of this matrix will be 3 into 3. Okay. So these are the 3 type of matrices, and then we are also left with another 3, children. So we'll be quickly looking into that. The next matrix that we have is called a rectangular matrix. Okay. So I'll just write this down. This is called rectangular matrix. So what is a rectangular matrix, children? As the name suggests, it is a matrix in which number of rows and number of columns are not equal. So what you can be writing, that number of rows is not equal to number of columns. Okay. So basically all those matrices which are not square can be considered as a rectangular matrix. So the basic examples can be taken like this, children. Suppose this is A, B, C, D, E, F. So clearly here I have the number of rows in 2 as 2 and number of columns is 3. So what I will be writing, this is 2 into 3. Or other examples can be 3 into 4 or 3 into 5. So these are all the examples of a rectangular matrix. Means the number of rows and number of columns are not same. Okay. Then we will be moving to the next type of matrix, children, that is called a zero matrix. So what is a zero matrix? I will be telling you, as the name suggests. If each element of the matrix is 0, then it is called a zero matrix. Okay. So how do you represent that? See, this is called zero matrix. Okay. So what you will be writing, each element is 0. Each element is 0. So what can be your example? 0, 0, 0, 0. Or else like this, 0, 0, 0. So means number of rows and number of columns are nothing to do here. If all the elements are like this, 0, 0, 0, then this will be considered as your zero matrix. An easy one. That all the this are this, and then this is also called what, children? This is also called null matrix. Okay. So this is also called null matrix. And then we will be moving to the last type of matrix, that is called diagonal matrix. Okay. So what is a diagonal matrix, children? In diagonal matrix, first of all, the condition is, there are two conditions, children. In diagonal matrix has to be a square matrix. It's a mixture of square matrix. And another condition is that all the elements are there that should be 0, but the diagonal matrix, in the diagonal you should not have 0. Okay. I'll show you the example. All elements except diagonal are 0. that is why it's called diagonal matrix. So first of all, what is my prime condition, children? That it should be a square matrix. So square matrix means this is my example of square matrix. And then we'll be satisfying the next condition, that is the diagonal should be there and the rest of the things should be 0. So AB is my diagonal. So this is diagonal and other elements will be 0. So this is called diagonal matrix. Or else you can be taking like this as well. So this is 0, A, B, 0. So means in the cross like this, if you are getting elements and the rest of the elements, suppose if they are 0, then that will be considered as a diagonal matrix. Okay, so this is an example, and then we'll be now moving to the next type of matrix, children. There is one more matrix. If you just see, these are the important ones, and if the see one more, that is called unit or identity matrix. Okay, so this is identity, or this is also called unit matrix. So this is also a diagonal matrix, children. Similar, it's just that the diagonal elements which are there, that will be unit, and unit means what? 1. So you'll be writing like this. So suppose this is my 0, 0, and then this is 1, 1. Or else I can be writing like this. If I want to take off the order 3, then this is 1, 0, 0, 0, 1, 1. Sorry, 0, 1, 0, not 1, and 0, 0, 1. So this is an example of unit matrix wherein you can see the diagonal elements are what? The diagonal elements are equal to 1. Okay, so these are the types of matrices which are there. We'll be moving on to the next thing, children, that is called a transpose of a matrix. So this is a transpose. So what is a transpose of matrix, children? It means, children, what are we doing here? We are just interchanging the rows and columns. Okay, so suppose this is my matrix A, whose order has been given by 2 into 3. So suppose I am just writing down like this. So this is A, B, C, D, E and F. So the transpose means what? Here you are interchanging the number of rows and columns. Interchanging rows and columns. Okay, so this is rows and columns. So what, as the name suggests, children, now what is going to happen here? So if you are A 2 into 3, then transpose will be, first of all, you should be knowing that how do we denote transpose. It is denoted by A, and in the indices part you will be writing T and superscript, and then this becomes like this, children. See, whatever is here, this will become A, B, C, D, E, F. So this is called transpose. Okay, means whatever is there in the row part, you are making that as column, and whatever there is column part, you are making it in the form of row. And clearly now you can see, earlier it was 2 into 3 and now this has become 3 into 2. So what happens, suppose I have a number like this which goes 2 into 4, this upon transpose becomes what? This upon transpose become A. First of all, it is denoted by T and the order becomes 4 into 2. Okay, so this is called transpose of a matrix. If I want to explain you this with the help of another example in which I will be taking numbers. So suppose this is my matrix A, which is denoted by suppose 1, 6, 5, 4, 3, 2. Then what will be the transpose? First of all, it is written like this, and this will become like this, children. See, 1, 4, 6, 3, 5 and 2. Okay, so this is called transpose of a matrix. Then we have one more thing, children, that says equality of a matrix. So there are two conditions for equality, children. First of all, both the matrix should have same order. When you talk about equality of matrix, children, it is quite very understood that there are two matrices into this. So what is it means? First of all, they should have same order, and then second, what is there is the corresponding elements should also be same. Okay, so this is corresponding elements are equal, or else you can say they are same. So suppose I have a matrix A which is given by A, B, C, D, and then I have another matrix B which is also given by A, B, C, D, then I'll be say what, that this is matrix A which is equal to matrix B. So what are the two conditions here? If you see, the order of A is 2 into 2, for B also it is 2 into 2, and the corresponding elements means the first is A, second is also A, this, all are same. So this is called equality of matrix. Okay, all the elements are going to be exactly same. Okay, now we'll be moving on to the next thing, children, that is called addition of matrices. So when you talk about addition, children, first of all, the prime condition of the addition is that the two matrices should have same order. What does this mean, children? Suppose I want to add a matrix that has order 2 into 2, and then I can add it only with another matrix B which also has order 2 into 2. That is only possible. Suppose I have a matrix which has order 2 into 2, and if I want to add it with a matrix which has order 3 into 2, then this addition is not possible. So before performing the operation of addition, children, what do you need to see? First of all, you need to see that whether all the elements which are there, they should be having, all the matrix should be having same order, and then addition can be of more than 2 elements, children. That is completely fine. So if I am having another matrix C and it is also of order 2 into 2, then I can be adding. So it's not necessary that you can add just two matrix. You can be adding 3 as well, but the condition is that they should be having same order. Okay, and then how does addition take place, children? Suppose this general form is A, B, C, D, and then I have B which is given by E, F, G, H. So when we talk about A plus B, then what happens, children? Here A plus E, okay, B plus G, F plus C, and D plus H. These are all the things which get added up like this. Okay, so this is the matrix that I will be getting. Now if I want to explain you with the help of an example, so suppose I have here 2, 3, 1, 4, and another matrix I have B which is given by 0, 2, 3, 6. Then what will be the addition? A plus B equal to, this will be equal to C. This 2 will be getting added up first. So this is 2 plus 0, then 3 plus 2 here. Okay, and then 1 plus 3 and 4 plus 6. So what will be your answer? Your matrix will be 2, 5, 4, 10. So this is the addition matrix that you are getting. Okay, so this is the thing, and the next thing that we'll be looking into is the subtraction of a matrix. So in subtraction of matrix, children, suppose I am having a matrix A which is denoted by suppose A, B, C, D, and then condition is also same, children, that this should be having same order. And suppose I have another matrix B which is E, F, G, H, then upon subtraction A minus B becomes what? It becomes A minus E, C minus G, B minus F, and D minus H. Okay, so this is the subtraction that is happening, and if I want to denote this with the help of example, suppose I am taking a matrix A which is given by 1, 6, 5, 7, and then a B which is given by 5, 4, 9 and 11. Then what will be A minus B equal to, children? This will be equal to 1 minus 5, 6 minus 4, 5 minus 9 and 7 minus 11. So how much is this equal to, children? 1 minus 5 is equal to minus 4, then 6 minus 4 is 2, then it is minus 4 again and minus 4. So 3 elements you are getting as minus 4. So this is called the subtraction of matrices. Okay, so this is the way you are getting. And now thing is that, children, that there are certain properties that is being followed in the addition of matrices that I'll be telling you again. So this is suppose addition of matrices. So you already know that addition of any numbers follows some certain properties, children. So those properties are called, first of all, if you remember, that is called commutative property. So commutative property means, suppose I am having one number 2 plus 3. So this is equal to 3 plus 2. This is the property of commutative. So is this applicable for matrices as well? So answer is yes. For addition of matrices A plus B, this will be equal to B plus A. And when you just talk about the second property, that is called associative. So if you remember what is associative property, children, for any two numbers A plus B plus C will be equal to A plus bracket B plus C. So this is the property of associativity, and this is being followed in matrices as well. So if at all in a question you are being asked that you have been given two particular matrix and they are being told to just justify the property of associativity or commutativity, then you will be just showing this particular property, that A plus B is equal to B plus A, and if it is associative, then matrix A plus matrix B, first you will be adding up, and then you will be adding up this, and then here left hand side will be this, and right hand side you will be first adding up matrix B and C, and then you will be adding them up with A. So this is called property of associativity. Now you have to remember that addition of matrices follows both commutative and associative property. Why do you have to remember? Because when you are going to study the multiplication part, these two properties are not being followed. So I'll be discussing that when we talk about multiplication. We'll be looking into the last thing in the explanation part, children. The last thing in the explanation part is the additive inverse. So what is first of all additive inverse? The additive inverse is what, children? Suppose I have a number A. Okay. So what is its additive inverse? Additive inverse means that what should I add to this so that I can get the result as equal to 0. So clearly it is minus A. So this minus A is called the additive inverse. Okay. So this is called additive inverse, and this is there in matrices as well. So if I take a matrix A, suppose this is given by A, B, C, D. Okay. And then I take another matrix A. Suppose B I am taking, which is given by minus A, minus B, minus C, minus D. Then when you add them up, A plus B, this will be equal to what, children? See, A minus A will be 0, 0, 0, 0. Okay. Then B will be called the additive inverse of A. Okay. So this is called additive inverse, children, and it is always denoted by minus A. Suppose I have a matrix A which is given by 2, 3, 5, 7. So what is the additive inverse? It is given by minus A, which is equal to minus 2, minus 3, minus 5 and minus 7. So this is called the additive inverse. You are just reversing the sign of all of them. And why do we do this? Because when I add A and minus A, then all the elements are going to be 0, and this is what is called the additive inverse. Alright, so these are all the theoretical things which are there, which we will be considering in the exercise which is there. And now since we are done with the explanation part, children, I hope you all have understood these things. Now we can easily move to the exercise.